Hey guys, today we're going to talk about the Chatelier's principle. This principle states that if a system in a state of equilibrium is disturbed, it will undergo a net reaction that reduces the effect of the disturbance. A system is disturbed when a change in conditions forces it out of equilibrium temporarily. Equilibrium is the state in which opposing forces or actions are balanced. It also means that the forward reaction is equal to the reverse reaction. Net reaction is a phrase that refers to the shift in the equilibrium position to the left or right. Shift to the right is a net reaction that converts reactant to product until equilibrium is reattained, while shift to the left is a net reaction that converts product to reactant. The direction of shift can be determined by using the reaction quotient Q and the equilibrium constant K. Q If Q is less than K, the reaction proceeds to the right, forming more products. If Q is greater than K, the reaction proceeds to the left, forming more reactants. Q is increasing from left to right. So if Q is less than K, it must move forward to achieve the value of K. If Q is greater than K, then it must move backwards so that it can achieve the value of K. In other words, if a dynamic equilibrium is disturbed by changing the conditions, the position of equilibrium moves to adjust and reattain equilibrium. The three common disturbances or change in conditions are change in concentration, change in pressure caused by change in volume, and change in temperature. First, change in concentration. If we add a reactant, the system will consume some of the added reactant by shifting towards the product to reduce the disturbance. Thus, the equilibrium position shifts to the right when the component on the left is added. If we remove a reactant, the system will replace the reactant by consuming some of the products and proceeding towards the reactants to reduce the disturbance. Thus, the equilibrium position shifts to the left when a component on the left is removed. If we add a product, the equilibrium position shifts to the left to consume the product. If we remove some of the product, the equilibrium position shifts to the right to produce some of the product. Therefore, the system reacts to consume some of the added substance or produce some of the removed substance to make Q equal to K again. Second, change in pressure or volume. Third, change in temperature. If we consider heat as a component of the equilibrium system, a rise in temperature occurs when heat is added to the system, and a drop in temperature occurs when heat is removed from the system. Therefore, a temperature increase favors the endothermic direction, and a temperature decrease favors the exothermic direction.